Hello and welcome to the proportions and problem solving video. Ratio and rate. They're the quotient of two numbers or quantities. The ratio of numbers a and b can be written two ways. A colon b, or as a fraction, a over b. In a ratio, the units must match. In a rate, the units are different. In a proportion, you have two ratios or rates that are equal. So we'll use ratios AB and CD. We can simplify these by cross multiplication to where AD equals BC. We'll move on to an example. We want to solve for x. We get x plus 1 over x plus 2 equal to 3 over 4. So here we can use cross multiplication. Say 4 times x plus 1 is equal to 3 times x plus 2. And now we can solve for x with the distributive property. 4x plus 4 equal to 3x plus 6. We subtract 3x from each side to get an x, and subtract 4 from each side to get a 2. And we get our answer, x equals 2. We can always check our work, and we do that by substituting x back in. So we get 2 plus 1 over 2 plus 2. And does that equal 3 over 4? It does. For the next example, we will use 2x plus 3 over 4x plus 1 and set that equal to 4 over 3. Once again, cross multiplication. We'll set it up as 3 times 2x plus 3 equal to 4 times 4x plus 1. So here we'll get 6x plus 9 equal to 16x plus 4. Now we need to get our like terms together, so we'll subtract 6x from each side to get 10x on the right side, subtract 4 from each side to get 5 on the left side, and when we divide by 10, we get x equal to 5 over 10, and when we simplify, that is 1/2. We can check our work once again, and we can say that 2 times 1/2 plus 3 over 4 times 1/2 plus 1 is equal to 4 over 3. Top of the first fraction is going to be 1 plus 3. The bottom is going to be 2 plus 1. And does that equal 4 over 3? It sure does. Let's move on to the next example. Here it reads that a 170-pound person weighs approximately 65 pounds on Mars. How much does a 9,000-pound satellite weigh on Mars? So we're going to let x equal the unknown weight. So if we have someone who is 170 pounds on Earth, and 9,000 pounds on Earth, we will set that equal to 65 pounds on Mars over X amount of pounds on Mars. So we're going to have 170 over 9,000 equal to 65 over X. Now let's simplify the equation on the left first, as we can divide each one by 10 to make it 17 over 900. And now let's cross multiply. So we're going to get 17x equal to 65 times 900. 65 times 900 is going to equal 58,500. And we divide each side by 17, we're going to get a decimal. We're going to get 3,441.17647, and it keeps on going. So let's simplify this to the nearest pound. This would be 3,441 pounds. Example number 5. What is the best deal given the following prices for salsa? So on A, we have 10 ounces for 99 cents, which is 99 cents over 10. For B, given 16 ounces for $1.69, so we're going to go $1.69 over 16. And then we have 30 ounces for $3.29. So if we put these as ratios, we can find out how much per ounce. So on A, it is going to be just under 10 cents per ounce. On B, we are looking at a little bit over 10 cents per ounce. And on C, we're looking at even more, almost 11 cents per ounce. So we can look and see that our best price per ounce is going to be A. Now we're going to look at similar triangles. Similar triangles are triangles whose corresponding angles are equal and corresponding sides are proportional. So we're shown triangles ABC and triangles DEF, and we are told they are similar. So we have to assume that their angles are congruent. Side AC is going to be proportional to side DE, and side BC is going to be proportional to side EF. So we can set this up as a ratio. So we have to keep the same sides in one fraction. So 12 is proportional to 5, the same way that 10 is proportional to y. Now I kept the measurements for triangle ABC on the top and the measurements for triangle DEF on the bottom. You could flip-flop those as long as you keep the same sides on the top or bottom. So we can solve this by cross multiplying, and we get 12y equals 50. Then we're going to get y equal to 50 over 12, and we can simplify that 25 over 6. Make sure you read your question to find out what form they want it in. Here, a fraction is good enough for us. Move on to number 7. We're going to talk about some proportions. This is a work problem. As an experienced roofer can roof a house in 26 hours by him or herself. A beginner would need around 39 hours to complete the same task. How long would it take for the two roofers if they worked together? So we know that an experienced roofer can do the job in 26 hours. So that is going to be our time. A beginner does the same job in 39 hours. The proportion of the job done would be 1 over 26 for the experienced and 1 over 39 for the beginner. So if they work together, we don't know the time, but we know that they will do it in 1 over t. So we're going to add the two proportions together, and we should get 1 over t. So we have 1 over 26 plus 1 over 39 equal to 1 over t. Now we need to find an LCD. We know it's going to include t. If we look at 26 and 39, our LCD there is going to be 78, because 2 times 39 is 78 and 3 times 26 is 78. So let's multiply the entire equation by 78t. We should come up with 3t, because 78 divided by 26 is 3. We still have the t, plus 2t is going to equal 78. We combine our like terms, we get 5t equal to 78. So we know time-wise it's going to take 78 fifths hours. So if we divide that out, it's going to give us approximately 15.6 hours. Let's move on to the distance formula. The distance formula is distance equals rate multiplied by time. You will see this written as d equals rt. We can solve for r and solve for t to get two different but equal equations. So if we solve for r, we need to divide each side by t, and we get r equal to d over t. And if we want to solve for t, we divide each side by r, we get t equal to d over r. This equation, t equals d over r, will become important. So we will use this to figure out a few more problems. If we look at this example, the rate of the current in the creek is 5 miles per hour. A boat can travel 20 miles at a constant speed downstream in the same amount of time traveling upstream for 10 miles. What is the speed of a boat in still water? Well, we need to know what it's going to take downstream, upstream, our distance, our rate, and our time. And our time, as we solved earlier, is equal to distance over rate. Our distance downstream is 20, distance upstream is 10. The rate, we don't know, but we know that the current is 5 miles per hour. So if we're going downstream, we're going with the current, so it's going to be our unknown rate, r, plus our current of 5. And if we're going upstream, we're going to go into the current, so it's going to be r minus 5. So then our time is going to be d over r, which is 20 over r plus 5 for downstream, and 20 over r minus 5 for upstream. If we set up our equation as t equals d over r, we can substitute d over r in for the first t to have d over r equal to d over r. So if we use downstream first, we're going to get 20 over r plus 5, and then 10 over r minus 5. And I can see I've made a mistake there. That is 10. So now we're going to cross multiply again to solve the equation. So on the left we'll have 20 times r minus 5 equal to 10 times r plus 5. So we're going to have 20r minus 100 equal to 10r plus 50. So let's combine our like terms. Let's move our 10r to the left by subtracting 10r from each side. So we get 10r on the left side. Now let's move our constant of 100 over to each side, and we will do that by adding 100 to each side. So we should come up with 10r equals 150. And we divide each side by 10 to solve for r. We should get that our rate, still water, is r equals 15. Example 9. A driver took a day trip at two different speeds. She drove 100 miles at a constant slower speed and 320 miles at a constant speed, 30 miles per hour faster. If the time spent during the faster speed was twice that of the slower speed, find the two speeds during the trip. So we have two speeds. We have a slower speed and a faster speed. We need to know our distance, our rate, and our time. During the slower speed, our distance was 100. In the faster speed, it was 320. Our rate, which we don't know of the slower speed, is just going to be x. Now the faster speed was 30 miles per hour faster, so it'll be x plus 30. Our times are going to be t, but the time of the faster speed was twice that of the slower speed. So if that one on the faster speed is 10, or it's t, excuse me, the slower speed needs to have a time of 2t. So if we want to set these in a distance formula using time, we set as t equals d over r. And once again we substitute the d over r in for t. So if we want our slower speed to be the first one, we're actually going to multiply the d over r times 2 because it is really 2t. So let's plug in. So we're going to have 2 times 100 over x equal to 320 over x plus 30. So now if we distribute the 2 into the fraction, we should have 200 over x equal to 320 over x plus 30. So let's cross multiply again. We should get 320x equal to 200 times x plus 30. So we're going to have 320x. When we distribute on the left side, we're going to have 200x plus 6,000. 200 times 30 is 6,000. So let's subtract 200x from each side to get our x's together. So we should have 120x equal to 6,000. And when we divide 6,000 by 120, we should get x to equal 50. So that should be the time of the speed of our slower speed. Our faster speed is going to be x plus 30, which will be 50 plus 30, which is equal to 80. So during the first portion of the trip, we were traveling 50 miles per hour. The second faster portion, we were traveling 80. Let's move on. And that will conclude the video. Thank you for your time, and good luck with all of your assignments.